So the objective of this problem is to compute the support reactions in this structure. So the structure has two supports. Let's call it A and B. Support A is a pin, which means it has two reactions, a vertical reaction and an horizontal reaction. And I'm going to assume the vertical is upwards and the horizontal is to the left. On the right side, I have only a roller, which means I only have a vertical reaction, which I'm going to assume it's upwards, and I'm going to call it VB. Just for being consistent, I'm going to use a referential given by this diagram here. So I have a single body, so no internal releases, and I need three reactions, HA, VA, and VB, and to compute those I need three equations of equilibrium: horizontal forces, vertical forces, and moment to a point. That could be B. Doesn't really matter. A or B would both be simple solutions because they would lead to simpler equations, but I could use a point C if I wanted. So horizontal forces, I only have HA, which is to the left, meaning negative in that referential. So this, since this is the only one, must be equal to 0, meaning HA is equal to 0. Vertical forces, I have three vertical forces: VA, VB, and tan. VA, VB, and tan. VA and VB are upwards, meaning they are positive, and is downwards, meaning is negative. And the sum of all of this must be 0. I cannot solve this equation because I have two unknowns. So I have to find some other equation. For example, moments in relation to B. Now, the moment of a force in relation to a point is equal to the force times the distance measured perpendicular to the force. So this force would make it rotate like this around the x point. So sum of moments in relation to B, I'm calculating moments that cause rotation around this point. HA goes through point B, so it doesn't cause any rotation around B, meaning the distance between the force HA and point B is 0, so it doesn't really matter for now. VA, on the contrary, makes this rotate like this. So VA produces a moment, which is VA times the distance, 5, and it rotates opposite to this angle, to this direction here, so it's negative. Then makes the bar rotate like this around point B, so it's positive, and the distance is 3. VB passes through point B, so it causes no moment. So from here, I can get VA equal to 6 kilonewtons. I can now replace 6 here. The only unknown is VB, and I get VB equal to 4 kilonewtons. So my reactions are 6 kilonewtons on the left support, 4 kilonewtons on the right support, and 0 horizontal reaction.